I'm going to explain you the level 3 and level 4, which is a one with 9 buttons, and those buttons have no colors. So that means that in that case, the user is deciding what the colors of the buttons are. So as a reminder, the interface on the left is meant to enter a 4-digit code that is displayed on the top. In the middle, you have the machine that is asking you a question, and it's asking the user what color is the digit you want to type first. And on the bottom are buttons where the user clicks a button to mean yellow or gray. And in that case, the buttons have no specified color. So the user will have this color in his mind, and the machine will have to find out both what's in his mind and what digit is trying to type. And for this explanation, on the right side here, I'm displaying what the machine is doing in the background, what it's doing in its mind in a way. And there are 10 possible digits, so that's what we know. We know that at each iteration, the user is trying to type one of 10 possible digits. And you see again the buttons, the 3x3 matrix of buttons. They are gray, like we can see here, and we'll place colored dots after each click of the user. And the color of the dot will be the color of the digit when the user clicked. So for example, the first click I will do on these buttons will be displayed as a dot on the square I clicked, in gray for 0, in yellow for 1, in yellow for 2, etc. So what I'm going to do is I'm going to type the code 1, 2, 3, 4 in the interface, 1, 2, 3, 4, and I'm going in my mind to consider that there is the buttons, there is a yellow cross, so all the buttons that are along this cross are yellow, and the corners will be gray buttons. Okay, and that's in my mind. So I'm going to start with typing a 1 for my code, 1, 2, 3, 4. 1 is yellow, and I'm going to choose this center button to click because it means yellow in my mind. So when I click this 1, you see that there has been a dot that's been displayed on all the hypotheses, which represents my click. And this click is supposed to mean gray if I was trying to type a 0, because 0 was gray when I clicked on the button. And so you can see that if I was trying to type a 0, then this middle button must be gray. However, if I was trying to type a 1, this middle button must be yellow. If I was trying to type a 6, it must be gray because 6 was gray when I clicked on this button. But you see that contrary to the previous video, and the level where we knew what the buttons color were, all the hypotheses are still valid. The machine still is not able to say whether I'm typing a 0 or a 9. All possibilities are still open. Why? Well, because we don't know what the buttons mean, so we cannot compare these clicks with anything yet. So we continue, and now 1 turned gray, and gray are the corners for me, so I'm going to use the top left corner for this time. So I'm going to click on the top left corner, meaning gray, because 1 was gray before. As you see here, for number 1, the top left button is now has a dot on it that is gray, that represents my click. And you see now that we have 2 buttons that have been clicked. Still, the machine doesn't know anything about what I'm trying to do, really. It doesn't know if I'm trying to do a 0 or 1. It cannot discard any hypothesis. But we start having really different version of what the user might be trying to do and how it might be trying to do it. For 0, I might have clicked on 2 different buttons, but both would mean gray. However, on 1, I have 1 gray button and 1 yellow button, the middle one. On 3, it's the total opposite again. We have 2 buttons, the top left and the middle one, and both mean yellow. So if I was trying to type a 3, I would have used those 2 buttons, one to mean yellow each time. And so what we're going to do, and you see it coming, is I'm going to keep using those 2 buttons. And you see that what will appear is discrepancies in the data, where sometimes the user is trying to use the same buttons to mean two different things, and that doesn't make sense. It's inconsistent, and that's how we can discard hypothesis. So let's see what happens when 1 is again yellow. I want to type a 1. I'm going to reuse this middle square. Remember, I have a cross that is yellow in my mind. So I click on this button that for me means yellow. And what we see on the right is that this made 6 hypotheses disappear from view in a way, like the machine was able to discard that 2, 3, 4, 5, 6, and 7 are not the number I am trying to type. Why? And that's very interesting to investigate. So on number 2, you see that I clicked twice on the middle button, but on those 2 occasions, the first time 2 was color yellow, and the second time was color gray. So that means that if the user was trying to type number 2, then he used the same button, the middle button, to both mean yellow and mean gray. And that is, by the definition of how we are supposed to use this interface, is wrong. That means the user, if he was trying to type a 2, has made a mistake and is being inconsistent, so is not trying to type a 2. That is the logic that's going on. For number 3, it's the same. We had yellow and then gray. Number 4, yellow and then gray. Number 5 is the opposite. It was gray, then yellow. 6 and 7, the same. So we can discard those 6 hypotheses. However, we still have 4 hypotheses that are valid. And it's interesting to see that those 4 hypotheses have different models, different ideas of how the user might be trying to use those buttons. For example, number 0 thinks I use 2 buttons and they both mean gray. Number 9, however, thinks that the top left button means gray and the middle one means yellow. And so the machine still has these 4 competing versions of the user in his mind. Like, depending on what the user might be trying to do, it might be trying to do it in this specific way that we can see on the screen. And so we're going to keep going. So I'm trying to type number 1. I'm still trying to type number 1. And my corners are gray. 1 is gray. So I'm going to reuse this top left corner. So I'm going to click on the top left corner. And hypothesis 9 and 0 just disappeared, so were discarded by the machine. And hypothesis 1 and 8 remains. So what happened for number 0 is that on the top left buttons now could mean both gray, have been used to mean both gray and yellow. So it's not consistent, so it's discarded. Same for 9. So remains hypothesis 1 and hypothesis 8. And you see that the interpretation of those data is entirely opposite. So for the digit 1, you see that the top left button means gray and the middle one means yellow. But for 8, the top left button means yellow and the middle one means gray. So we have to find out which one is right? So we'll keep going. So number 1 is now yellow. So I'm going to click on the middle button. And now the machine just made a decision. So there is a lot that happened there. So let's first identify why we discarded number 8. We discarded number 8 because 8 was also yellow when I clicked. And so I used the middle button to mean yellow, but before I used it to mean gray. So this button, the usage of this button by the user, if the user was trying to type 8, is inconsistent and can be discarded. However, for number 1, you see that it still all makes sense. All the gray, the top left button has been used to mean gray all the time, and the middle one to mean yellow all the time. And so what happened is that on the left, the machine displayed number 1, because now it's confident that out of the 10 digits, the user, and me in that case, was trying to type a 1. And interestingly, you see on this grid that the color of the button now has changed to what is shown on number 1, because if I know the user is trying to type number 1, then I know that when he used the top left button, he meant gray. And so I can show it and display it on the button. So now I'm going to continue to type the second digit that we decided was number 2. And you see that again, as before, we're going to remove everything from there, but we are going to show now, as you can see here, the colors of the buttons. And that is to relate to the previous video where we had 2 buttons, one yellow, one gray. So now we know that the user is using those two buttons to mean the middle one yellow and the top left one gray. And so we'll kind of use that to speed up the learning. For example, let's try to type a 2. So number 2, we can click on the yellow button we already used. And that, because we know it's yellow, that is discarding half of the hypothesis, which is exactly like the previous explanation. So why? Because for 0, I clicked on yellow, but the 0 was gray, so it doesn't make sense. So it only makes sense for 2, 3, 6, 7, and 9. But now we have other buttons that are still black, and we want to use them, right? But I've never clicked on them, so what you will see is that by clicking on them, I won't give any more direct information to the machine if I only click once on them. For example, number 2 is gray. I'm going to use the top right corner because our corners are gray. And you see that this didn't change anything in terms of what the machine believes. Like the number 2, 3, 6, 7, and 9 are still valid hypotheses. But the interpretation of the top left button is different for each hypothesis. I'm still going to type a 2, and I'm going to use the bottom right corner. I'm going to use the middle right button for yellow. 2 is yellow. And you see that I've clicked 3 more times on 3 different buttons, and I still haven't made any more progress in my understanding of what the user is trying to do. But I have different versions of what those buttons might mean. So I'm going to keep using those 3 buttons on the right to type a number 2. So 2 top is gray, so top right. 2 is yellow, middle. And now we have found out that it's number 2 that I'm trying to type. Why? Let's see. Number 2, all the, there is in each button there is always clicks of the same colors, so it makes sense. But for number 3, you see there is a yellow and a gray and a yellow. That doesn't make sense. For 6, here on the top right, there is a gray and a yellow. Here there is a yellow and a gray. Here there is a gray and a yellow. And for all of them but number 2, there is inconsistencies in the use of the buttons. And so again, because we know we're typing 2, we display number 2. The machine display number 2, move to the next digit, and shows me here what the buttons actually mean. So we can continue. I'm going to type a 3 for the code 1, 2, 3, 4. 3 is gray, so I'm going to use the buttons I haven't used yet. 3 is yellow, gray. This has discarded a few hypotheses because the bottom left button has seen some inconsistencies, but not for all of them. And you see that it could be gray or yellow at this point. I'm typing a 3, so I'm going to use this yellow that we haven't used yet. I'm going to reuse this gray button. 3 is gray, bottom left corner. And this, like few clicks and 5 clicks, allowed me to identify 3 more buttons, colors of buttons, and the digit number 3. So now we know that we kind of start seeing the yellow cross and the 4 gray corner. So now we just have to reveal this if we want to use it to type digit number 4. So we type digit number 4. You see that here most of the colors are mapped. 4 is yellow. I'm going to use the bottom of my cross, yellow cross, and yellow again. And now I can use any button really. So 4 is still yellow. I'm going to use a yellow. And 4 now is gray. I'm going to reuse a gray. And in 4 clicks, we found out that 4 was the only option possible, and most, in that case, like number 2 was discarded, not because there was inconsistency in the middle bottom button, but because I used a yellow click. I clicked on a gray square when I meant yellow if I was trying to do 2, and this is not valid. So that's how the machine is working, and is figuring out that I was trying the code 1, 2, 3, 4. And in that case, what's interesting is that I decided in my mind as the user on the fly what the colors of the buttons were going to be, and I also decided what the code was. And the machine, by using this principle that I just explained, was able to find out both what I was trying to type and how I was trying to type it. That means that on this bottom buttons, you can decide whatever you want. If you want to have just one yellow button on the top left corners and all the other one gray, you can use it that way. And the machine, by looking for inconsistencies in the use of the buttons with respect to all the 10 hypotheses, will be able to find out both the digit you're trying to type and the meaning, the colors of the buttons you're using in your mind. So I invite you to try this out on the link below this video.